Oh, let me get the projector fired up.
Stats. Right. Yeah, no, unless it's an array, sometimes that string can become either one element or as many letters.
Check this out.
Yeah. This. Doing this. Too bad. Look at what I did for
Somebody's got something that smells good.
Okay, sorry about that. I just wanted to get the stream taken care of because we had a bunch of people ask to do the stream tonight and wanted to make sure that that was like working, which it is now. Cool. So, and I thought I had this all set up last night, and then I, of course, started it up again, and none of the settings were correct, so I had to kind of fiddle with them to make it work. But welcome back. Some of you were here last night, some of you watched it from afar, and that's cool, whatever works for you for that. Last night we did discuss testing, writing a bunch of little tests using a part of JavaScript called assert, or in our case, console.assert. And then we followed how to use tests in order to build up some code, and finished up with how to be able to use like web-based testing. And so that was kind of fun last night, and it was sort of optional, but it does help, especially with like the design of your applications, if you can use tests to help to build them and then to verify that they're running the right way. So with that said from yesterday, if you have questions about testing or about like the live stream, like I don't know if anybody had questions after watching that video yesterday, but if you do, let me know, and I'll do what I can to try to answer those while I'm here. If not, we can also ask questions about Tic-Tac-Toe, the project that we're working on. I just want to kind of touch base and see where people are at in terms of where they feel like they are in the project, and if they need some help, or if maybe there's something I can help clear up if there's some confusion around it. So anything for testing or Tic-Tac-Toe project that anybody wants to talk about before we start talking about stuff for tonight?
I guess
Sure.
sort of dealing with how to pass the output of one function as the input to another function,
Okay.
when then that function is going to be in an event listener, because when you do an event listener, you can't give a function something to like a parameter, right? Because it calls it immediately if you put the curly braces. Does that make sense?
So what with the event listener, that function that is the event listener will always receive one argument at least, which is the event itself,
Right.
that causes the event listener to receive an event, right?
Yeah.
So the event itself has a bunch of parameters on it. One of them, or properties on it. One of them is like the type, and then there's other ones like the event.target. And so you can pass arguments to other functions that the event handler calls after the event handler gets called. Because the event handler can call other functions. But you're right that when the event handler gets called, it always receives that event, but it can be kind of tricky to pass other arguments to the event handler in addition to the event, right? Because you as a programmer are not the thing that's calling the function. The thing that's actually calling the function is the browser.
Right.
Yeah. So what I typically do with event handlers is that I'll have the event handler take the event itself, and then if there's something that you want to pass to another function, like let's say that the event was triggered by hitting like a submit button, right? So you want to get, for example, like with the Markdown project, you want to get the content inside the text area. What you can do when the event gets triggered by clicking that submit button is that you can have there be a function called that gets the content inside the text area and then like assigns that to a variable or passes it somewhere else and then assigns it to a variable. So it could pass it to the marked global object that you get when you include the marked library in your page, and then get the output text from that, and then put that into another area inside the page, such as like a div.
Right. This was more for adding asterisks and doing the bolding.
Okay, so for adding asterisks and doing the bolding, there's a bunch of different ways that you can go about that.
Yeah.
But what you probably want to get is when you select some text, there's this there's a selection start and selection end that you can use, and the selection start and the selection end, those are properties on the selected events. So or I believe that's what it's called. It's the event that fires when you select something with your cursor inside the browser. And so what you can do with that is you can like take those properties, selection start and selection end, and you can assign them into a variable that's visible outside of the event handler. So you could have a variable called like selected text, and at first it's nothing, but then when you select some text, it actually assigns some state to that variable.
Right.
And then when your bold button gets clicked, it can check on the state that's inside of the selected variable to determine where should I start bolding and end bolding. So that's just one way to go about it. So you can think of it as like, you can have a function that gets called as an event handler, and in order to pass state to another function, it can do that by setting a variable that the second function can see in its scope when it gets called. Because if you set it inside of some global variable, then it's always available to some event handler, okay, that gets called. There's other ways that you can do this that might be cleaner or like easier to grow as your application gets really big, but that might be like the simplest path to start following. Or I should say the easiest path. It might not be the simplest in the end, depending on how big your solution gets.
So yeah, okay, that makes sense, I think.
Okay. The other thing you could do is if you don't want to set it into a global variable, which I've mentioned before aren't like great when your application gets big, you could set it in as a property of some object that is either global itself or is in the scope of the function that gets called as a handler. All right.
Okay.
Is that like any clearer?
Yeah, I feel like it gives me something to chew on.
Okay. Maybe I can do like a video of this or something to try to because it's hard to show without actually like doing the code.
Right.
Which I could do, but I might eat up another 15 minutes or so doing that. So why don't we see if there's time later tonight to talk about it?
Cool.
Is that cool?
Yeah.
Okay. Anybody else have questions about like the tic-tac-toe project or the testing stuff that we did yesterday? Now that Connor broke the seal, it's easier to ask after somebody breaks the seal, right? Yeah.
I have a fun bug that's mutating my whole array and finishing the whole board.
Okay, so you have a bug that's mutating your whole array and is finishing the board.
Yeah, so it's basically just filling out my whole array with the letter O.
Oh,
and
okay.
I
Oh,
tried
yeah.
to make it so that it's not the function that I'm referencing that results in this bug isn't really changing the array, but I think I'm missing like a new keyword or
Okay.
something that's,
Okay.
but I thought it was a fun bug, which is why I brought it
Cool. All right.
Try explaining it to a rubber duck.
up. No, I didn't.
No rubber ducking yet.
Um,
We could try to do a rubber duck session during the break or something, and take a look at it then.
yeah.
I like fun bugs. We can also get a review on that code from a TA or an instructor, like between classes, between this class and Thursday's class, so that and that goes for anybody too. It's not just this doesn't just go for Missy. If you have like a bug or if you want some help, like, you can always reach out to us and ask us for a review. In addition to just waiting for us to review your code. So if you have like a tricky situation that you need some guidance on, that's a surefire way to get us to take a look at you. Is you can hit us on Slack. That's the easiest way, and we'll do what we can to take a look at the code. Just so make sure that you push your code. You know, oftentimes it's easy to forget that the code that's on your laptop isn't the same as the code that's on GitHub, unless you push. Anybody else have any more like fun bugs or cool questions that they want to ask before we talk about objects again?
I accomplished some refactoring that was given to me by TA.
Awesome. Okay, so you did some refactoring that was asked of you by
Well,
TA?
I don't know if it would be considered refactoring, but basically I had 4 functions where 2 would do. I made 3.
Okay, so you had 4 functions and you sort of condensed them down to 2 functions.
I had a function for player X's turn, a function for player O turn, and then
Uh-huh.
one function for both.
Got it. So you made a more generalized function that could clear either turn.
Yes.
Okay, cool. That's awesome. How was that?
Hard until it was very easy.
Yeah. Why do you think it went from hard to easy though?
I'm not sure at this point.
Okay.
That it was hard until it was easy.
So, yeah, it's an interesting description. It was hard to figure out how to do it until it was easy. Sometimes I've found that hard problems are really hard because of my particular way of looking at the problem. And when I rearrange the problem in a different way, suddenly it's easier. Does that make any sense?
Well, I think it was distance and time away from it, and then coming back.
Oh,
and seeing it.
yeah, well that is for sure a good way to solve problems. If you are really stuck on a bug, this is a good rule of thumb. If you're stuck on a bug and you spent more than an hour on a bug, your performance on a bug tends to scale in a particular way. So usually it goes something like this. So this is performance, and this is time here. And so like you're starting at 0 on both axes, right? But these aren't the same scale axes or whatever. So you usually start with like fairly low performance on that bug, and then it goes up to some point, and then it drops like precipitously until you walk away from it for a while. And then when you come back, like your performance is super high again. So if you are in here, in this area, and you're like doing really well, and you think you're like making some progress, that's cool. But this time right about here is like minute 45 or so, I found. That's like, for me, if the bug is really hard and I don't know how to fix it, and I've spent more than 45 minutes, my performance on that bug just like starts to drop through the floor. And then if you continue to work on the bug without walking away from your computer, your performance goes down dramatically because you get really frustrated. But then if you walk away, so like imagine that this is like walk away time. So I'm going to make this dotted. This is being away from the problem. So go for a walk or whatever. So this is go for a walk. Then when you come back, your performance goes like through the roof. Or sometimes you solve it while you're on a walk, which is even better. So there's, this is a pretty well-known, this isn't just like a programming thing, this is a pretty well-known problem-solving technique. Like it goes all the way back to like Benjamin Franklin, at least in terms of people who have written about it, and probably older, where people will kind of work on a problem and then they'll walk away and their brain kind of works on the problem in the background even when they're working on other things. And then like maybe as they're like out on a walk or like washing the dishes or cooking dinner or something, be like, oh my God, I know the answer. And then they like stop what they're doing and go and change like 2 lines of code and the program runs the right way. So if that happens to you, which I'm sure it will at some point if it hasn't already to you, then like congratulations, that's like a cool, hurdle that you get to go over as a programmer. And if it doesn't happen to you or hasn't happened to you yet, then it will in the future. I can almost guarantee it. So cool. I'm glad that you brought that up, Ira. Any other questions or comments or things people are thinking about that we want to talk about before we jump into lessons?
I just want to say that part of the reason that refactor might have been hard is because I was a little deliberately vague with my instructions there. Sorry.
Oh, me? No, I got a lot from Alex too. That was
nice.
you guys also
Okay.
a lot of similar.
Excellent. It wasn't just me. It wasn't just me being
No, his was more vague, but
vague and obtuse.
Cool. So today what I'm going to do is, this is kind of, it's kind of set up in a weird way, but so what we're going to do this on Thursday is that we're going to be building to doing tic-tac-toe in the browser. So you've gone and you've written tic-tac-toe on the command line, and many of you have gotten pretty far on that or completed it. Has anybody completed tic-tac-toe on the command line so far? Cool. So like 1, maybe 2, we're like
When-
close.
I've got a few.
We
things.
program the smart learning aspect of
If
it.
you can get up to the point where you program it so that just 2 people can play, like and they're human beings, and they can finish a game, and it says like X has won, or O has won, or it's a draw, then that is, in my mind, like the core of tic-tac-toe, and you've completed all of the core stories of the project. Cool. So we got at least 3 or 4. That's great.
Now, if you put a number in there that's already been used,
Yeah, okay. Yeah. I got you. So you have like a few edge cases that you need to account for.
Yes.
Okay. So I'd still say that you're like 95% of the way there. There is a tough one, which is that you have the artificial intelligence play against you. If it just picks a random open square, that's a challenge. But if you have it play as best it can possibly play in that's called optimal. If you have it play optimally against you, that's a pretty big challenge. And if you were to get that to actually work, so that if every time you played against it, at the very best you only ever tied or lost against the AI, then that's like pretty great. That's a pretty big challenge. Like a lot of people who I know who are programmers wouldn't be able to do that. So you should congratulate yourself if you get that. Because tic-tac-toe is what's known as a deterministic optimal game. So there's always a known best move for every move that you make on the board. So every time you make a move, there is a move that can counter that move perfectly every single time. And so in the best case scenario, if you had 2 computers that could play optimally against each other, they could only ever tie each other. And if you've ever watched the movie War Games, you have seen the moment at the end of the movie where like the computer's playing against itself, playing like nuclear war. It's not playing tic-tac-toe, but The analogy is the one that they use between tic-tac-toe and nuclear war, and so it can't win. It only ever ties, and so then there's the line the only way to win is to not play, and that's true about tic-tac-toe. The only way to win the game, if you play against a suitable foe, is to actually not engage in the game, because you can only ever tie. If you both play the very best game you can play. That's not true about every single game, but it is true about tic-tac-toe, which is kind of a fun way to test that you've written a really good AI, is that if it plays against itself 100 times, it's going to have 100 draws. And they're going to be different moves on each game, right? Cool. All right. So don't feel like you have to do that, though. That's a pretty big challenge, like I said. So there are ways to do a little research and to help you to figure out how to do that, to how to actually write the program that can't lose against itself, or also can't win against itself. But if you get to the point where 2 human players can play against each other, and you can determine if the game has won or lost or drawn, then you have completed the core parts of the challenge. I just want to reiterate that. Okay, so what we're going to talk about to lead up to that is that we're going to go over some more object-oriented JavaScript, because JavaScript has a bunch of different ways to do objects. We've talked about one of those ways so far. There's at least 2 more that are really common, but we are trying to push you down a pathway of least resistance with objects, because there's, like I mentioned, there's a bunch of different ways to do objects in JavaScript, and some of them are harder to use than others. As you kind of grow as a JavaScript developer, you'll figure out why we've kind of suggested this path to you, versus just saying oh, you can do it any way you want. So we're going to introduce another way to you today, in addition to talking about JavaScript object-oriented features. So a little bit of review, then some extra content, and then talking about object-oriented design and some things that you can do to make your life better when you use objects in JavaScript or in any other language, not just in JavaScript. All right? So those lessons are right down here: object-oriented JavaScript and creating objects. And then if we can, we'll get to object-oriented design tonight as well. We'll try to get through those. We'll see how far we can go. This one's going to be mostly about half review, and then about half new content. This one, in creating objects, there's definitely going to be some new content. And then in the design, we have to just sort of discuss why you might want to do things a certain way. Okay? All right, so let me pop this over here. And my face is out of the frame now. It's so different to be over here. Okay, so I'll just kick that way. Let's do object-oriented JavaScript. Close this down for now. Just check on the stream really quick. Looks like we're good. Great. So let me come down here. Let's show these slides. And I'm going to blow this up a little bit just to make it a little bit bigger. That'll be good. Okay. So JavaScript is what's called a hybrid language, or the other way that this is described is what's known as a multi-paradigm language. So what that means is we've already taught you a bunch of different ways to write programs using JavaScript. The very first way that we taught you is what's known as a procedural approach to problem solving. So a procedural approach would be make a variable, make that variable equal to 0. And then when the player makes a guess, right, check to see if their guess is equal to some secret number that you as a computer have created randomly, okay? And then tell the player whether or not their guess is higher or lower than some secret number. That would be if the player is guessing whether the number, what the secret number is. If you want to invert that, and the player has some secret number, then as a computer, you might make some random guess between two ranges, or a range between two extremes. So you have one extreme be 0 and the other extreme be 100. And you would make some number between those extremes and ask the player, is your secret number 50? And then they would respond to you as a computer, oh, it's higher than 50 or it's lower than 50. And then as a computer, it's up to you to make your range smaller in order to account for the new information that you get back from the player. And you just continue to make that range smaller until you end up with guessing the player's secret number, or determining that the player is cheating and that they've picked a number that is outside the range, or they've changed their number at some point during the game, right? So that was the first project we did, which was the guess the number game. And a lot of the ways that we taught how to solve that was by writing a procedure that you read from the top and continue reading down until you get to the bottom. And at the bottom of the procedure, you usually have the result. Now you might have to loop inside of that procedure, or you might have to skip certain parts because of a conditional, so an if statement, for example. But you're essentially either reading from the top and then jumping up to some part inside of the program over and over again until you're done, or you jump up and then skip certain parts based on the state of your program. Procedures are the first type of programming languages because when computers were first made, they followed procedures. We didn't have these other types of programming paradigms like a functional program or an object-oriented program, and I'll get to what those mean in a little bit. But procedures were like the original style of programming. When Charles Babbage and Alan Turing designed computers, what were to become computers today, they thought of their designs in terms of following some procedure. All right. JavaScript has a lot of features about it, though, that make it really good as what's known as a functional programming language. And functional languages use functions as opposed to using things like conditions, and as opposed to using things like loops. So a functional programming language, a purely functional programming language, doesn't have loops at all. It just uses recursion, and it doesn't have the limitation of having some stack depth that it could finally max out. And it doesn't have conditions, it calls functions that return true or false. And that true or false will determine what you do next in the program. So functional programming languages, the most common one that's modern is known as Haskell. There's another really common one called Clojure. There's another really common one called Scala. There's a couple of older ones. One of the original languages that sort of fell into that functional paradigm is called Scheme, which is like it's a derivative of this family of languages called Lisps, which I'm not going to go into today, but there's a bunch of different languages that fall into this world. Object-oriented languages, JavaScript is a part of them because there are in fact objects in JavaScript. Another really famous object-oriented language is called Java, where JavaScript derives its name from. Now they don't have any similarity other than their names. They're not related at all. But around the time that Java became popular, JavaScript was being written and designed. And for a marketing kind of approach, somebody suggested naming it JavaScript. So that's where the name came from. But it doesn't have any other connection to Java other than that name similarity. But there are really a bunch of languages that fall into this camp. There's another language called C++. that's object-oriented. It also does other types of programming as well, like JavaScript does. And then there's some called Ruby, and one called Smalltalk, and another programming language called Self. And there's a whole bunch. And they sort of pioneered, Smalltalk and Self pioneered the design of object-oriented languages. And in object-oriented languages, everything is an object. So in JavaScript, it sort of breaks this mold a little bit. Like there are, in fact, like primitive types in JavaScript, such as numbers and strings and true and false, right? Undefined, null. Like you can't call a method on null, okay? But you can call a method on the number class, which the number 42 is a part of. It's just that if you want to call a method on it, you have to wrap it in parentheses first. Otherwise, it'll think that you're trying to make like a decimal, right? So you're trying to, not a decimal, a floating point number, like 42.1345 or something like that. In some languages, though, like in Ruby and in Smalltalk, everything is in fact an object. There are no not objects. In Ruby, you can take a number like 1, and then you can call like .add on it, and add another number to 1, which is really weird. Or you can create some method called like toString on an object, and say like 1 toString. It'll give you the string representation of 1. JavaScript doesn't go to that length of extremes, but what it does allow you to do is to write really big programs and like nicely organized programs using objects and having objects talk to each other. And we've learned that objects in the world of JavaScript are things that have properties, and those properties might be values or they might be other objects, and that we can use those in order to sort of model our problem and then create a solution based on the model that we've set up. So we're going to talk about how JavaScript implements some object-oriented language features now, and kind of explore what we mean by the way that it does that. So we kind of know what an object is already. So this is a nice definition of an object, though. It's that an object encapsulates or puts together state, which is what the value of some variable is right now, with behavior, or being able to call functions and procedures with that variable or with that data. Okay? So this is also oftentimes called state and behavior. So when you have an object, let's call it a circle object, right? It has a radius, and that radius is 1, and then it has a circumference method, and the circumference method takes the radius and multiplies it by pi, and then you get the radius of 3.14 or whatever with additional decimal points. That is the combination of state, which is radius, and behavior, which is circumference. Circumference is a procedure that depends upon the state of the circle at a given point in time. And the nice thing about that is that they're put together in the same thing. The thing that we're talking about is the circle, and that thing can have both the state and the behavior locked together. And you could have multiple circles. You could have circles with a radius of 2 or 3 or 4 or 42, and then when you call circumference on it, the behavior of calculating out its circumference will run the same procedure, but it runs the same procedure with different data, so you get a different output. I don't know why somebody's calling me right now. Sorry about this. That is definitely a robocall. It's a robocall. Yeah.
John Oliver bit on robocall.
Yeah, everybody's talking about robocalls these days. Everybody's talking about robocalls. Okay, so this is a really simple definition, but and that means that some people are going to disagree with it, but it's a sort of a nice, compact definition of what an object is. All right, there's definitely different definitions here, but this is the one that we like to use because it's really succinct. Okay, So an object encapsulates state and behavior. So the state is the data in the object, or you can think of data as just values, right? So numbers, strings, true, false, null, undefined. And then you can have collections of data, such as you can have like an array with a bunch of different numbers in it, and that's an object that has a bunch of properties, and those properties are data, right? So even though an object might have like, let's say you had an invitation list, and the invitation list has a property on it called invites, or invitees. That invitees might be an array of like names, might be an array of strings, okay? So you can think of the data of that object as being the invitees, and the invitees have their own data as well. So it's sort of like data all the way down. And you're building that model up of your problem so that you can solve it with code later on. Your behavior are your functions or your methods. So functions and methods, remember, are very similar. A method is a function attached to an object's property. And to be a real method, it should use state that is bound within the object as well. So if a function just says like hello world, it's not, if a method says hello world and it's not using any state from within the object, it's a method that doesn't really need to exist, right? It would be better off being just a regular function that the object calls or something like that. So a method uses the state of the object. Now, there's this other term here called messages, and what is that? So what we mean when we say messages is that if you had an object that sends a method to another object, it calls a method on another object, what you're doing is that you're sending that second object a message that is the name of the method that you're trying to call. Okay? So if your person object needs to call the send invites method on the invite list, it would say invite list.send invites. But what it's doing when it does that is it's actually sending a message with the value, the string value, send invites over to the invite list object. And that's what we mean when we say the messages that we're sending back and forth. And in our definition, our encapsulation means to put these things together, right? To put these state and these behaviors together. And then the converse of that is to keep dissimilar things apart. So if you have two parts of your program that aren't related to each other, maybe they belong in different objects. Rather than having one object that just has a whole bunch of methods on it that are not related to each other in any way, you could have a few different objects that sort of model the different parts of your program. So in the tic-tac-toe program, for example, you could have a board object, and you could have an object called game, maybe, and the game has like a current player. It switches between O and X every time it gets called. And then it has like, the game might have like a winning board method that takes a board and determines if somebody has won and who that is. So there's just, what we mean by keeping dissimilar things apart is how do you break up the parts of your program so that they live in the object that best represents that part of the model. And that might mean that you have a few different objects in your program. And not just different individual objects, meaning like different circles. You don't just have like 5 circles in your program. You might have a circle and a drawer and a canvas object. And in order to draw the circle on the canvas, you have to have an instance of circle, and you have to have an instance of the canvas, and you have to have an instance of the drawer. And those 3 objects work together in order to give you the results of a drawn circle on the canvas inside of the web page or whatever it is you're building. And all of these objects, they respond to the messages that they receive through their interfaces. So a object has these methods on them, and when they receive a message of the same name as the method, the object calls that method on itself. And the nice thing about this is that you don't have to define how an object does that. It does it for you. As soon as it receives that message, it's going to call the method on itself of that same name. And that's why when you try to call a method on an object that doesn't exist, right, you can send a object a message, right? But if you try, and if it's a property, it'll give you undefined if it doesn't exist. But if you try to call a method with the parentheses, open and close, on an object that doesn't define that, you get an error. You know, and it says whatever that message name is not a function. So it might be like if you're calling a circle and you say circle.color and you haven't defined the color method on a circle, it might say color is not a function. Okay, and that'll usually be a name error, if I remember right. Could get that wrong, but I think that that's right. Okay, so I've mentioned that in pure object-oriented programming, methods are only directly used two sources of non-local data. All right, so a method should use object state, right? But sometimes methods can take parameters from the method call, and they can take properties of the method's own object. So this is called like the state of the object. And we'll talk about how this relates to this term called law of Demeter, which we're going to talk about that in a slide or two. And all of the other data in a pure object-oriented program are manipulated via messages sent to other objects. So what that means is that if you want to get at data inside of an object, you have to send a message. You're not allowed to reach into that object and mess it around and change stuff if you're not that object itself. Sort of like, you know, an object is sort of like a closed system, and you have to send a message to it in order for it to give you back some data or to change the data itself. Any questions on that? Sorry, I moved through the first few slides kind of quickly because we've talked about this like a week or two ago. Okay. So here's an example. All right, here's some example code. You have a rectangle. It has some state. It has a state height, and it has a state width, right? And it has this area method, which is a function that returns this dot height times this dot width. So it's using the state height and the state width of the rectangle in order to compute whatever that area is, and then it returns that when you call the area method on the rectangle. So if you say A equals rectangle dot area, area gets called, right? Gives you back 80, 8 times 10, and then sets it into the variable A. Okay? So this code is object-oriented. It follows the rules because it only accesses data held inside the rectangle, and it accesses it using that magic pointer this. Remember that this is a special variable. It doesn't mean anything when you're outside of an object. And if you are outside of an object and you're in like the global scope land, does anybody remember what this points to when you're not inside of an object and you're just like at the very top level of your program?
The window or global?
Yeah, it does. That's exactly right. It points to the window or the global object. In Node, it points to the object called global. In the browser, it points to the object called window. And they both will always exist in either of those two places. This is a big point of confusion. Other programming languages don't have that same kind of confusion. Usually if you try to reference this outside of an object, you'll get like undefined, or you'll get null, or you'll get an error. Like any of those would be totally suitable. But the fact that this points to some global object is a big point of confusion in JavaScript. So I want to keep bringing that up so that when it happens to you, you can remember, like, oh, that's right. This points to the global object or to the window. And I'm not inside of an object right now. That's why this is pointing to something else. Or that's why I'm getting undefined instead of what I think I should be getting. Cool? Any questions about this? We've seen this before, right? Everybody remember? We saw this like a week or two ago. Is it ringing any bells? Okay. Any questions so far? Yeah?
Just a point. I do remember seeing this, but I know it's like a super important thing.
Yep.
And so that, yeah, it's good that we're seeing it again. I think the first time
Yeah.
it was like just sort of start thinking about, because I
Yeah.
don't remember much from it, I guess.
We talked about it, I think, right before we started Zorkington. Because Zorkington it can benefit from using objects as its approach. You can do it procedurally if you want, but it can benefit from using objects. You could have every room be an object, for example, and then when you go into that room and you pick something up, you're altering the state of that object, right? And so when you go back into that room later, now that thing isn't there. So maybe like a note isn't on a table, or a sandwich isn't on a board, or something like that. So, yeah. Like I said, you can do it procedurally, but it can be trickier than using objects. And I bring this up because different approaches, procedural, object-oriented, functional, they serve different solutions better than others. Like, each one of them is sort of its own tool, and sometimes that tool is better served for a certain purpose. It's really hard for me to describe all the situations that object orientation is going to be great for, and all the situations that functional programming is going to be great for, and all the situations that procedural is going to be great for. What I'll say is that as you get more experience writing code, you're going to get a really good sense of when it's the right time to use objects or functions or procedures to go about your particular problem. Okay, cool. So we're using an object now, but we're not object-oriented here. This is not what we would call like really good object-oriented design. So using the rectangle object from the previous slide, right? The following code, not so object-oriented. So our p variable is equal to calculate perimeter, and it takes a rectangle. So this is a function that takes a rectangle, and that's this function right here, calculate perimeter, taking a rectangle. And it says rectangle.height times 2 plus rectangle dot width times 2. And height and width here are owned by this rectangle object. This rectangle object actually holds the state. But where does the behavior live? Where does the behavior live in this example? Anybody tell me?
The function.
Yeah, this is exactly right. It lives within the calculate perimeter function. And so although we're using an object here, what we're doing is we're using the object as a bag of state. And we're not allowing the object to do what it would be really good for, which is to hold state and the behavior that uses that state. And so instead we have to add it inside this function. And this can turn into a situation where you have like sort of an imbalance between where the data lives and where the behavior lives. So sometimes this is okay, but most of the time it's better to put the method on the object itself and to have the functions exist as a property of the object. And those are methods. So in this case, object-oriented design, we would calculate the perimeter, right, in a different way. Does anybody have a suggestion on how we would do that if we wanted to make this more object-oriented? What would we do with the calculate perimeter function?
You put it inside the object definition.
Yeah, you could. Missy, did you have a suggestion?
That was it.
Yep, okay, cool. So you can take the calculate perimeter function and you can make that method on the rectangle object that then points to the same definition, except for instead of it taking rectangle, it doesn't have to accept any arguments anymore, because it can reference itself by saying this. It could say this dot height times 2 plus this dot width times 2. All right, so let's say that. This is it. So great suggestion. This is exactly what Missy and Ron suggested. Why might this be easier to use in the future? Like, why do we even avoid code like this and instead move it to code like this? Why do we do that? Anybody have a suggestion? And I'll give you a clue. What if we change the rectangle? What if we change how the rectangle works in the future somehow? Why would this be easier to deal with than this? Missy?
If you change the rectangle, then if you change the property names or something, you would probably notice in debugging earlier that if you later tried to reference the function and then got an error on the property names being valid.
Yeah, that's about right. So I'll just reiterate what you said so anybody listening can hear it. If you change rectangle, it's easier to notice where the changes occurred from the calculate perimeter method, because the perimeter method is right on the object. So you can just look to see, okay, did we change the name height? Did we change the name width? Maybe we added another property or something. And because the perimeter method is located alongside the height and the width properties, if something changes inside that object, it's really obvious to the rest of the object's definition, wherever we define that to exist, what needs to get updated. But if we had a function like this function could be defined anywhere in our program, or maybe it's even defined in another file somewhere. Maybe we're being really fancy and we've broken out our code into multiple files, and we're including the files in such a way that we get this behavior from somewhere else. We need to have understanding of what's inside of rectangle from this calculate perimeter function, which might accept other kinds of objects. Maybe calculate perimeter doesn't just accept rectangles, maybe it also accepts circles, or maybe it also accepts triangles, or maybe it also accepts pentagons, or whatever, hexagons, octagons, right? And we would need to account for all those different shapes and the names of whatever their properties are inside of this function. But if we just had that same function as a method exist on all those different shapes, and it was called perimeter on each one of those shapes, well, now we have however many perimeter methods as however many shapes we have, but it's defined differently for every shape, and it lives alongside where the data lives. So when we end up having to change it for whatever reason, then we can see very obviously what has actually changed. So this is an important distinction. Good object-oriented design makes programs easier to change in the future. It might not necessarily make them easier to write at this moment, but it'll make them easier to update at some point in the future when we end up changing our program, either because a new feature has come in, or because there was a bug, or because we've changed our design approach to our problem. Okay, so just to remind ourselves, there's a couple of different definitions of objects in JavaScript. So we have this idea of objects as, I think we've brought this term up before, but it's called a hash. So when you have an object that just has data, it's just data, no methods at all, Sometimes people refer to that as a hash, which is just like a collection of a key, which is a name, and a value, which is an actual piece of data. And it's just a mapping between that key and a value. So name, Joshua Burke, or age, 35, right? Or state, Vermont. There's no methods, it's just keys and values. But object-oriented means that we have to add in the reference to the object self. So we have this value, or this variable rather, that its value is the object. We can create objects by using this special new keyword, which is really nice. And we can also pass behavior and even state from a template to a specific instance of an object by using this special keyword called proto, or whatever object it is, like number, string, whatever, dot prototype. And then there's this other keyword called class, which we're going to talk about today. We don't really use proto very much. It certainly can be used, and it used to be very useful, but class is now a newer feature of JavaScript that's come about in the last, let's see, I think it was officially allowed in like 2015, so that's 4 years now. So I'm saying that because it's been around for 4 years. That means that probably over 98% of browsers support this. 98% of people who are visiting your web page. That doesn't mean that every browser supports it, but a lot do. And there's ways to be able to get it to work even in older browsers as well. And you can go visit the MDN if you want to see those ways. They're called polyfills. And when you look at a feature of JavaScript, MDN tells you if you have an older browser that doesn't support this feature, here's a little bit of JavaScript code you can include in your page to allow it to support that feature, which is really nice of them to do that. There's other tools that you can use that actually include that right in your page for you when a person visits your page as well. Okay, so inheritance means that if you have a template, or known as a prototype in JavaScript, you can create derivatives of that template. And so you could have sort of a template version of a circle, and then you can create specific instances of circles. Maybe a circle with a radius of 1, or a circle with a radius of 3, or a circle with a radius of 10 or 42, or whatever. And the other part about object-oriented design, which is a little harder to do in JavaScript, is that you can hide certain states. So you can show certain state to the rest of the program, but you can also hide state. And this can be actually a little more challenging to do in JavaScript because of limitations in the language that exists today. In a couple of years, it'll be easier, but right now it's actually a little harder. And I'll try to explain why without kind of getting too bogged down in all the nitty-gritty details. So we have some more stuff coming up soon, but let's just jump ahead really quick. So when we're designing the model of our program, the solution that we want our program to represent, we can think of objects in a couple of ways to kind of help our design thinking. So objects generally are things that can be described and can do other things. They can take actions, right? They have behaviors. So the objects in your program are usually the nouns in your description of the solution. So if you were to write down your solution using English language, like in sentences, when you name nouns like car or building or circle or shape or person, those can typically be substituted in for the objects that are in your system. And the methods on those objects are usually the verbs. So the actions or behaviors that your object can do, all right? The attributes of your objects are usually adjectives, like when you compare them to English language. And this special word, which I haven't shown you how to use yet, classes, are categories of whatever it is that you're building. So I mentioned before, classes are sort of like a template for a specific instance of an object. You can create something that's sort of like a bunch of defaults, and then you can create specific versions of that. And I'll show you how to do that in a few slides. So, in this case, our category is a noun that describes a type of thing, but not the thing itself, not the specific thing. So when we speak of circles, circles all have certain properties, right? In particular, they are all going to have a radius, right? And they are all going to have a circumference, and they're all going to have an area. And maybe some circles, if you want to draw them on the screen, would have like a color or a border or something like that. So those are sort of like the properties of our category, properties of our class. All right, I'm going to switch to the next slide and see if we can get the sirens to die down a little bit. I don't know, we'll see. So if we remember our lesson from a couple of weeks ago, we have the ability to create objects using our literal syntax, which means that literal syntax is this curly brace on the left and the curly brace on the right, and in between are what? What do we have in between those curly braces?
Colon.
There's a colon in there, but what is the colon separating?
A key and a value.
A key and a value, yeah, or a name that's associated with data in this case, right? So our name here is color, and our data is the string brown, all right? So this is our name, and this is our value, our key or our value. And this will create as an object. This is a very simple object. It only has one property, and that property has a simple value. And we assign that object to our variable dog. So dog, the variable name, dog, points at this object. This object, though, it lives somewhere else. Dog is not the object. Dog is not the object, which is sort of a weird distinction to kind of tease apart. Dog is the label that gets associated with the object. So dog gets put on the object's box. And then inside that box, we have ourselves a name color and the value brown. Okay? It's easy to make the mistake to think that dog is the object, but it's the sign that's on the box that contains a dog. All right. So we give this object the property color after we create it, and the value is brown, and we assign that variable dog to point at that object. Questions so far? You all know this, right? We've covered this. We're going to go into some things that we haven't covered yet, though. So just to reiterate, this is how our computer's memory works. We have two compartments. We have a reference, so a label is a reference. Label gets attached to things. And we have instances, which is the actual data itself. And sometimes this is referred to as the stack and the heap, all right, in our memory inside of our computer. So the stack is where our references live, and the heap is where the data itself lives. All right, so think of the heap as like a giant warehouse, okay? And we have, at the door of the warehouse, we have a big board with a bunch of labels on it, and those labels point to certain columns and rows inside of our warehouse. So we know exactly where to go to get that actual content out of the box. Okay? So you have the label, it points to a value. And a reference includes things like parameters and local variables that are inside of objects. The instance contains the real data. So every reference points at the location of an instance of the data. All right? And in JavaScript, every reference is the same size as well. This doesn't exist like this in every programming language, but in JavaScript, they're either going to be 32 bits or maybe 64 bits in size. So it's a whole bunch of data that makes up a big chunk, and that chunk is 32 bits or 64 bits. So our dog name in our stack points to some place in memory where this object lives, that has the label name color and the value brown. And that lives in this other place in memory called the heap. Okay. So our literals here, they create instances of these objects. So Abby, the name Abby, points to a dog with the color brown. And the name Lula points to a dog with the color of brown. So are these the same dog? Are they the same dog?
No.
Someone say no?
Yeah, I said no.
That's correct. They're not the same dog. That's right. So if we changed Abby's color to be tan instead of brown, or Lula's color to be gold instead of brown, it doesn't affect the other dog. They're different. They are actually like different compartments in your computer that hold electrons, essentially, right? Different electrons. They're not the same electrons. And so they refer to different objects. They just have the same values. Okay. We've mentioned that side effects on things can be tricky. So if we had Abby equals a dog with a color of brown, and Abby equals dog. Wait, where's dog? Hold on. And Lula equals dog. Hold on a minute. Is this wrong?
Yeah, because you've already assigned.
New dog equals color brown.
You can't reassign.
Yeah, but I'm gonna have to fix this in a minute. So here's what we're getting at. A variable is a reference to an instance, all right, which is someplace in memory. And if you have several references to the same instance, weird things can happen here. So here's what we're gonna do. Imagine that this line here, Abby equals dog, doesn't exist for a moment. Just imagine this second line doesn't exist. And it says Abby equals color brown, and then Lula, instead of saying equals dog here, just have it say Lula equals Abby. Okay? So Lula equals Abby, Abby equals this dog color brown here. Because dog at this point doesn't exist yet in our world, unless he's trying to pull it over from a different
I
slide.
think he was saying let dog equal color brown, let Abby equal dog, let Lula equal dog.
Got it. Okay. So if we say that Lula's color is equal to gold, then has Abby's color changed in this case? We have two references to the same object, which is this association between the name color and brown. And if we change one of their colors to gold, does the other color change when we have just two variables that point to the same thing?
Well, you reassigned Lula to Abby.
You did. You assigned Lula to Abby, that's right.
So when you change Lula's color, you're changing Abby's colors also because you reassigned Lula to Abby.
Yeah, that's right. Yeah.
But if you just change Lula without assigning Lula to Abby, you'd only be changing Lula's color.
That's right. So let's see it. Let's see it so that everybody else can see the same thing.
Oh, I think I see what he was getting at there. He set this Abby object, and he says Abby is equal to dog.
But where's dog?
Dog is, when he's assigning Abby to dog, dog is the new label on that object.
So if we said let Abby
But you've already assigned
equal
Abby,
color,
it's gonna throw an error because
Brown.
you're doing another left.
It would need to be
Abby equal dog.
Yeah.
so Abby equal dog. Here's the problem.
And then dog is not, okay, yeah.
You see what I'm
It
saying?
would have to be dog.
So let me refresh this really quick. So if I did it like this though, I can make this work. Just give me a hot second. So if we say let dog, not God, dog equal color brown, and then we say let Abby equal to dog, and then if we say let Lula equal to dog as well. So now we have our dog object, which is our color brown. Is this big enough for everybody to see? Now if we say Lula dot color equals gold.
Abby's gonna change also.
Yeah, so Abby now dot color is gold. Because they're pointing at the exact same place in memory. When we change that piece of memory, it changes for both. If we had what we did before, where we say, let's say if Abby were equal to a new dog, which with a color of brown, and Lula were equal to another dog with a color of brown, then if we say, in this case, Abby is a dog with a color brown, and if we say Abby.color, well, let's do exactly what we had before. Lula.color equals gold. Abby now has not changed because in this case they're now different objects. Okay, this is a really common mistake that people make with objects, which is why we're kind of hammering it. Object variables that point to objects, are always a reference. They're always a reference. So it's important to just kind of commit that to memory. And sometimes variables like if we had color, and color is equal to the string blue, and then we say like color equals the string red, well, color is obviously going to be equal to the string red because we've changed its data to be an actual different value rather than a reference to an object that might have some values inside of it. Missy, you had a question? This is the bug you had? Reference versus value? Yes, it's super common. You will all experience this bug at some point in your programming careers. With JavaScript or with other programming languages, it will bite you eventually. And by knowing that this is the kind of behavior that exhibits when you have this bug arise, you can very quickly debug it. But if you don't know about this kind of behavior with references versus values, you will bang your head against the wall for hours trying to figure this out. And it's very frustrating.
I just want to say that I did this like 2 weeks ago. I had this bug in a website I was making, and it took me so long just staring at the code to be like, oh wait, I'm hitting the reference, not the object.
That's right. Yeah. Super common. Really good programmers make this mistake all the time. I've said this before, I'll continue to say it. 90% of bugs is thinking that the world is one way when it's some other way. And if you can figure out what way the world is, you'll be able to very quickly debug 90% of your problems. Not all of them, because occasionally your logic will be wrong or something like that, but those are only a small percentage of your bugs. Most of the time, it's you think the world is X when the world is actually Y. And, the definition of your world will change, but that's usually the problem.
Tell me about it, man.
Okay, so variables are properties of some object, right? So the dot operator, in this case, we know about this, I'm just rehashing it. It sends the message color to the Abby object, and we look up the value, and if it's brown, we say Abby is a brown dog, okay? And if it were Lula and the color were golden, it would not log this out because Lula is gold, not brown. And the dot operator, which is the actual character period, we'll call that dot in a lot of different scenarios. I'll say Abby dot color or something like that. Sometimes I'll shorten it to just say Abby color, which I don't even mean to do. I just kind of do it out of habit. We're saying send the message color to the object Abby. That's what this is doing to JavaScript. And just to prove it, I think I still have Abby and Lula here if I blow this open again. So if I have Abby, okay, and I say Abby.color, okay, obviously it's brown. what this is doing is it's saying Abby, square brackets, string, color. Under the hood, that's what's actually happening. It's looking up the value of color in the collection Abby. Okay? This is called accessing the property of the object, and it gives you back brown. So sometimes, right, we'll have weird bugs that are hard to reproduce. But if like Abby had, if I said Abby, favorite toy equals bone or something like that. I'm just making this up. I can't send Abby.favorite toy. Right? I can't do this. This doesn't work. That's not valid syntax. So I have to say, well, what's the Abby object? Well, it's this object that has a color of brown and a favorite toy of bone. Favorite toy has a space in it, which is bad style for sure. You shouldn't do that. But it does exist, and I can get at it by, instead of using the dot operator, I can use the square bracket operators with a string like this. And it doesn't matter if it's single quotes or double quotes. Either one will work, just like this, and that's perfectly fine. That'll work. And in fact, anything you put inside of these square brackets that evaluates to the string favorite toy will also work. You could take an array of favorite and toy, you can combine them with a space in between them, and you'll still get the same thing. So just show you that really quick. If I were to have this and I said an array of two strings, favorite and toy, and then I said dot join with a space like this, and then I put that inside of here, that still gives me back bone because it evaluates to the string. Just to prove to you that all it cares about is what string it is. And it evaluates whatever's inside of the square brackets, and that's how it knows what to send as a message. So I'm sorry if I belabored that one for too long, but I just wanted to make it clear that there's nothing like super complex happening there. Okay. So the instance method is a property on the object, so we can add it. We can add a method at any time that we want. We just have to define what it is that this property will point to. And so in this case, we can say abby.speak. So .speak is a property that we're going to define on this object itself, on this object. And it's going to equal a function, and this one is going to equal console.log bark. So if I had Abby again, just really quick, and I add this on, so if I said abby.speak equals a function, and that function is going to do console.log bark. Okay, so Abby now has this extra thing called speak that's a part of her. She can speak, and speaking is a function, and it has some code that makes it run. Okay, I could go into this and try to find that code for you, but I'm just going to let you trust me that this speak will work. But what about Lula? Does Lula have a speak now? She does not. So by changing Abby, we have not changed Lula here. Lula stays the same with her methods. The methods don't get added onto Lula just because we've added them onto our dog Abby here. Okay? Just keep that in mind, because we're going to get to the point where we can start changing some things in a little bit. Let's do a more real-world example. Let's have a circle, which is equal to an object with a property radius and a value of 2. And we say circle.circumference equals a function. So now we're going to use a function that actually references some state on circle. When we say return math.pi, this is a global a global name that we can use anywhere inside of JavaScript, just like we can use the name string or the name number or other classes that are available in JavaScript's standard library. And it has on it a property called pi. It has on it a property called pi, which is really nice because it is the value of pi to some number of digits. And I think it's like 16 or 18 or something like that. And then we say times 2 times this dot radius. So this should give us back the circumference and 12.566370, yada, yada, yada. Okay? The this here will allow that function to operate on many states that are on this circle. So if we had a bigger circle and we would then have, say, circumference equals circle.circumference. Well, what do we just do here? What's going on here? We're saying bigger circle equals a radius of 4. And we're saying that it's bigger circle dot circumference equals this circle dot circumference. Well, how the heck does that work? What is this circle's dot circumference? What's its definition?
It is half times.
Yeah, but why can this circle's circumference work on this other circle? Why does that work? Aren't we using the word this? Why does the this update?
This always refers to whatever it's in.
Yeah, this always refers to whatever it's in. So when we create a new function called circumference on this new object, and we attach the definition to be equal to this other circle's circumference function, the definition can apply to the original circle or the new circle that we've defined here. It's not specific to this circle up here. It can apply to either one. It can apply to either one. Okay? So that's kind of interesting. Let's see what we mean by this. So if I copy some of this, and I put it over here. So I have my circle with a radius of 2, and if I say circle dot circumference and I call it, I get back the 12.566 and whatever. So if I have a bigger circle down here, and I say bigger circle dot circumference, I have to spell it correctly, this is the hardest part, equals circle dot circumference. Now my bigger circle dot circumference, when I call it, I get back, of course, the bigger value. But if I can reassign the function, what if I took the function off of the object altogether? What if I said var circumference equals circle dot circumference? Well, what does circumference equal now? Equals a function. It just equals a function. So circle is equal to this function that doesn't have an object. It doesn't have an object. So what does that mean? What if I call circumference now? Circumference. What if I call this? What would happen? Anybody know? Anybody have a guess? You know all the things that you need in order to have the answer, but you don't know that they go together. Who thinks that this will be a number? Put your hands up. If you think this will be a number. Okay. Who thinks it won't be a number and it'll be like null or something? Who thinks it'll be like undefined?
I think it'll be undefined.
And who thinks it'll be like not a number? Okay. We got 2 votes from 1 person. That's always fun.
I just don't think
It'll be not a number. Why though? Why would it be not a number? What is this?
getting treated like a string.
What is this? Oops. Sorry. Let me back this up.
What's that?
Let me go back to, I didn't mean to do that. Let me go back to the console here, or I should be able to go back to the console. There we go.
Is it trying to call the radius of, it's trying to call the radius property of the object this?
Which is what? When you're not in an object, what is this pointing to?
The global world or something?
Yeah, the global object is trying to get to the window's radius. So what if I did this? Window.radius equals 1.
Then
Now if I call it, what would it equal?
radius, it would be 1.
It'll be, the circumference will be, I call it a second time. Up here it says not a number, but here it says this, right? Here it says this. Let me do one more. What if I said, no more window, what if I said radius equals 2? Now if I call circumference, what is it going to be? So what is now window.radius? It's 2. But I didn't say window.radius equals 2. I just said radius equals 2. I just said radius equals 2. So when we create a global variable, where does that variable go? Onto what?
Window level.
Goes onto the window. That's right. So if I said color equals blue, what's window.color now? What's window.color now? It's blue. So every global object we make, every global variable we make, by accident or on purpose, gets put onto the window object. It's not really global in the sense that it just lives on its own. It in fact lives on a global object. And if we send the message color and there's no recipient of the color message, well, it goes to the global window instead. This is a very common point of confusion, so I am bringing it up for that reason. There's a very weird behavior as well that can happen between the document and in the window, and I just want to let you know that if you have an ID on the documents somewhere, like let's say you have an ID on your inside of your body of your HTML, that becomes a variable with that name, whatever that ID's name is, on the document object. So if you had an ID of input somewhere on your document.input is that element. That is a tricky bug that has bit me before with a student while I was trying to debug some problems with them. So just keep in mind, if you're using global variables in your overwriting things, sometimes you can kind of have some really weird, tricky behavior that's hard to debug. This is one of the reasons why I try to minimize the number of global variables that are in all of your programs. Okay, let me see if I can finish up a slide or two before we break. So if we, inside of an object, this is separate from what we just covered. You always have to remember to use the this variable when you're referencing state. Otherwise, which radius is this going to try to look up? The window, exactly right. Good. So everybody's picking up what I'm putting down. If you reference a global variable, or variable I should say, inside of a function, if that variable is not defined inside the function or inside the object, it'll go to the scope outside the object. And in this case, this object doesn't have any scope outside of itself. The next level up is the global, and the global is the window. So it'll look for window.radius, which doesn't exist. And so in this case, you get nan when you call circumference. Okay? So unfortunately, a lot of people consider this a mistake in JavaScript, and it has bit lots of people. So we just keep bringing it up because we don't want it to, when it does bite you, and you know, it's like going outside on a summer day, you're going to get bit by a mosquito. You just got to know what to do. So when it bites you, slap the mosquito. Know how to get rid of it. So I want to bring up a little bit of a difference between functions and our friends the fat arrow before we take a break. So in most functions, right, the this is managed automatically when the function is a method on an object. So if you have a function that's a method on an object, you call this from within that function, well, you're going to get the parent object that it's on. The thing is that when you have a fat arrow, this actually points to whatever this is right outside of the definition of the function. So if you're defining the function in an object, this won't point to the object when you're using a fat arrow function. I'll show you what I mean in a moment. This will instead point just outside of that object. And whatever the this is there. So if your object is defined just on its own, not inside of another one or anything like that, and you use a fat arrow to define a method, as sometimes people do, your this won't point to the object itself. It'll point to whatever this is just outside of the object, which is super confusing. But in the case of fat arrows, they're really, really useful for defining functions, but I don't recommend using them for defining methods. So when you're defining a method on an object, you don't want to use a fat arrow, you actually want to use the full name function. Because when you're defining a method on an object, you almost always want to use some state from that object, and it becomes much harder to do that when you use a fat arrow. There are ways to do it, but I don't want to teach them just yet because I have to get some other things first before they'll make sense. All right. However, when you use functions as a callback, so a function that's not a method on an object, the this in that case, when you are using it as a callback, will work as though the this is whatever is using that callback, not inside the function itself, which can be really useful. So I oftentimes, when people want to define a callback function in line to where it's used, using a fat arrow in that case is a great usage of the fat arrow functions. Okay, that is a frustrating point of JavaScript's this keyword. When I say these sentences, I have to be very careful about the words that I use so I don't double use the word this, for example. But we will see some examples when we're doing callbacks. What I recommend is that for callback functions, unless you have a really good reason to, try to avoid using a object's method as the value of a callback function from somewhere else inside your code. So for example, if you had a click handler and you had some method on a board object and you wanted to use that method, and that method depended on the this variable, you are probably going to run into a bug when you do that. So in that case, I would recommend making another function that's not part of board, that is just a function that lives on its own, that could be used as a callback function. Okay? I'll try to show some examples of that. There is a way to deal with this. I'll show you what this problem looks like in a moment. We did, however, see it just a minute ago. So when you call a function on an object, this is actually set. But when you detach the function, as we experienced a moment ago in the interactive coding, like we set g equals a circle dot circumference, and then we call g, the circumference definition that we had earlier in the lesson had a reference to the word this. And the this in that reference will be equal to the global window. And if there is no radius on the global window, it would return us a nan, right? Which is what we saw like 3 or 4 windows back, or 3 or 4 slides back. So the solution to this is a thing called binding, which is, this is new. None of you have seen this yet, unless you've read ahead or you've read the MDN without me directing you to, which is great if that's what you've been doing. But if you want to use a method as a callback, a method that's on an object, you have to do what's called bind it. And what we mean by binding it is that if you had a module object with x equal to 42 and some function that returns this dot x, so it would return the value of 42 from within this object. If we wanted to get that function on its own, we would say let, unbound get x equal module.getx. That takes this function getx and detaches it from the object and assigns it to this variable unbound getx. This is going to give you undefined because there is no global x. There is no global x. But if you do this line here, bound getx equals unbound.getx.bind, and then we pass the reference of module back into the call to unbound getx. This is very weird and confusing syntax. What it's doing is it's taking the this from module and passing it into this function, which is this return this.x. So now this refers back to the actual module object, and it works just fine. It works just fine. I'll give you an example of this in just a moment. So right before we take a break, we're going to take one in 1 minute. If we did, I have a couple of circles here, right? So if I had radius 2, circumference, window, circumference, bigger circle. So bigger circle dot circumference is this 25 point blah, 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 right? And circle dot circumference is 12.5666 blah, blah, blah. So here's where things can get tricky. We just saw what bigger circle's circumference is, but what if I did bigger circle dot circumference dot bind circle? What's that going to equal? Anybody tell me? Which of the circumferences is it going to equal when I do this? Lance?
12.566.
That's right, or it should. And then
And you have to call it a bigger circle.
then I have to call it, which is weird. So it's calling the circumference function, but it's binding the this to the smaller circle instead of to the bigger circle, which is weird. And here's why it's weird. We think of the methods as part of the object. The method name is totally part of the object, but the function that the method points to, you notice when I said dot circumference dot bind taking circle, what it gave me back was a function. The function actually lives on its own. And even though it's the value of the method name, it still lives on its own in the heap where all the data lives. And because it lives on its own, it needs to know what its this is. And that's the reference that gets updated when you pass the message bind to an object. This is one of the more confusing parts of JavaScript objects. So I'm going to leave you to think about this for 15 minutes. We'll come back at 8:30, okay? But don't feel like you have to get it all today. But this is a big, it's kind of an important part of how JavaScript objects work, because when you understand this, they make a lot more sense. Okay? So let's come back at 8:30, and we'll see you all then. Okay? And we'll talk about classes, which are a lot more fun than bind. Because classes are where things kind of are fun to build objects out of. Cool, cool. Okay, so we are back. Hope everybody had a chance to kind of mull over what we were talking about. Keeping in mind that I don't usually introduce the word bind in teaching JavaScript for as long as possible because it reveals how complicated JavaScript can be under the covers. I try to keep those covers like pretty tight so that people don't like peek underneath and go like, oh my God, what am I dealing with here? Because people used to think of JavaScript as like a really complicated object-oriented language for just this reason, because it has like some really weird properties about it. And now JavaScript, you can avoid a lot of that if you just avoid doing certain things and not going and using certain features of the language. But I'm going to talk to you about some of the better ways to make objects and not get yourself kind of tied up in a bind, right? Every once in a while I'll make really bad puns. You don't have to respond to them. I actually don't recommend you respond to them. Okay, so how to make an object. We can do it a bunch of different ways, okay? We can make them from scratch, which we've done. You can also use this special word new. Maybe some of you have done this, like when you create an array and you want to fill it. So do you remember we demonstrated how to make, if we did let my array equal new array dot, let's see, can we do new array dot fill, hold on, do 10 like this, dot fill with high. Let's see if this works. So if I say my array, yeah, I get 10 with highs. Okay, you remember that? It's kind of weird syntax. The new word and then the name of the object that you want to make. And then this one has the special argument it accepts. It accepts this initial argument 10, which means how many things in an array do you want? And does anybody remember why we have to call fill when we create an array with 10? What's an array of 10 without the fill afterwards? Does anybody remember that? We talked about it really briefly.
Is it empty array?
It's empty. Every single element in it is empty. So let's do another one. Let's call it empty. So if we say empty, empty, and we say new array, but no fill now, just 10. So now empty is 10 empty items. So it says empty times 10. Empty just means that each one of them is like undefined. There's nothing in it. So if I say empty empty at 0, if I can type, it's undefined. And if I do empty at 9 or 8, it's undefined. They're all undefined. Its length is 10, but it doesn't have anything in it, which is just means that it's a bunch of emptiness. Okay, that's a weird thing about arrays. I actually really don't like that. I wish that it was like 10 nulls or something like that rather than 10 undefines, because it behaves like it has something, but it doesn't have anything there, which is very annoying. But you can do something kind of funny with it. You can say for let element, let me call it item of empty, and I can say in here console.log like, hey, it is, and then I can add in whatever the item is, which is going to be, every single time, it's going to be the same thing. Let's see if I have this lined up correctly. I think that I do. Oh, I'm missing a semicolon, of course. It has to go right here, not a semicolon, a parenthesis. And it says, hey, it's undefined 10 times. It just says that 10 times. That's why it sort of like gives me this 10 here. So each one is undefined, right? Every single time. It'll actually do it only 10 times. It won't do it infinite number of times, which is really useful. But it doesn't like give me anything here, okay? I could do a for loop inside of here and actually put values in if I wanted to. So I could say, you know, for let I, while I is less than the empty dot length I plus plus, and then I could assign each item to a value. But by default, arrays are just empty. I'm gonna get off of that tack now. I didn't mean to get down that branch so much. The last way to make objects is with prototypes. So you can make objects with prototypes, and what the heck is a prototype? Well, a prototype is a template that you can build an object from. It's sort of like a default object of a particular kind. So if we made a default cat object, and then we made a new cat from that default cat, well, now what that means is that if we don't assign the cat a breed or a color or a weight or an age, and the default cat has those properties, our new cat will just get whatever the default cat has. Because whenever we look up the property on the new cat and it doesn't find it, it'll go up one to the template and say, well, what is it in that template? And that's where it'll look for it if it can't find it on the default cat. So let's see some examples. Let's see some examples, because these will make more sense. So here's the scratch object. We've seen this now several times. So circle, radius equals 2. Circle dot circumference equals a function, math.pi times 2 times this dot radius. So we get 6.28. Something, something, something. I'm sorry, no. 12 something, something, something. Sorry, my math in my head wasn't working correctly. We had an area, and we set it equal to this. Well, radius of 2, area is our function, and when we calculate the area, it's 12.5663702, So this is the same thing that we did on the prior set of slides. It's the same thing. Should look familiar. So if we wanted to add some more stuff all at once, we can do it all at once instead of doing it in pieces. This is doing it in pieces. We create an empty object, then we added a radius property, then we add the circumference method, then we add the area method. But this object on the next slide over here is created all at once. So whether you make it all at once or whether you make it in pieces, it's fine. They both do the same thing. This way, if you know everything you need right away, this is maybe more direct. You know where everything's defined. It's a little easier to find your stuff. The other way is more flexible. If you don't know what everything is until maybe later in your program, you can add stuff in at that later point in your program. Still, though, you get the same results. You get the same results when you call the same methods. Doesn't matter if you define them up front or if you define them later. It's cool either way. And let's see here. Okay, so now let's talk about some stuff we haven't talked about yet so much. Creating objects with this new word. These are oftentimes called constructors, okay? And what a constructor is a constructor is a function that's called with the new keyword instead of with the parentheses. There's still parentheses involved, but you have to have the word new with that function as well, or else it won't work the same way. And what new says is that create me a new empty object, sets the object's prototype, which we're going to talk about in a little bit, set the this pointer to whatever object I'm creating, call that function, and then return the object at the end. Return the object at the end. Unless your constructor function returns a different object for some reason. That's like a special case that I think is pretty uncommon, so I'm not going to go into it. So that's what a constructor function does. Has anybody heard about these in another context? If you programmed in other languages, you might have heard of these before. Okay? Like Java in particular, C# in particular, Python, Ruby. I don't know if anybody's done any programming in any of those languages, you may have heard these terms get bandied about. All right? They're the same ideas, they just apply in a slightly different way. Any questions about this so far? We're going to get into some code here in a slide or two. Okay, cool. So there's a special keyword class. Let me zoom in on this a little bit. See if I can zoom in. Yeah, I can totally zoom in. So there's this class keyword, and this came about in 2015. This was the conversion, just a reminder, from the historical version of JavaScript, which is called ES5, which has been around since the early 2000s, to the more modern version, which is called ES6, which was certified and official as of 2015. Okay? It's also sometimes called ES 2015, which is very confusing. So I just want to let you know that those are the same things. And what they are is that one of the things among many new awesome changes that came to JavaScript was a special word called class. And it's a keyword which is a bunch of syntactic sugar, which just means that it's a more ergonomic, more comfortable way of doing something that maybe takes a little more work, but gives you the same result. So the dot keyword, that's syntactic sugar. So when you do dog.color, syntactic sugar. That's syntactic sugar for square bracket, single quote, some name, single quote, square bracket. So in the same way, the class keyword is syntax sugar for some other code that allows you to create an object template in a very similar result, but with a different set of actual lines of code that do it. All right? And what it does is that it builds on top of JavaScript's prototype-based object inheritance. When I said before you could have a dog, and the dog could have a template called dog that has like a default color and a default size and a default weight, or same thing with a cat. Well, maybe their prototype is animal, okay, and animal actually has the property species on it. Maybe cat doesn't have a species, but animal, its prototype, does. And so an animal is looking for the species property, and it doesn't find it, where cat is looking for the species property, it doesn't find it on itself. It looks up at its animal prototype, and it finds it there. So in this case, we can create a circle template object. All right? And our circle template object has this special method called the constructor. And you note that the syntax is different. Can everybody see the syntax is different here? There's no word of function here. Does anybody see the word function here? It's not there, right? It doesn't exist. That's because when you make this line, when you write this line of code, and it gets called, but when the object gets created, what it does is that it creates a property called circumference that points to a function. All right, it points to a function, and this one doesn't happen to take any arguments. There's no arguments to this function. However, this one does. This one does take an argument, and that argument is radius. So in this case, this constructor function is a special function that gets called when you use that keyword new. When you use the keyword new with a capital C circle after it, and then a number, that number will come in here into the radius. And it'll get populated into these properties, this dot radius and this dot diameter. So that's a little weird because this dot radius and this dot diameter are properties on the object that gets created. So this looks a little different when you set it up. But what it does is that the radius variable comes in and substitutes with this reference name here, radius, and this reference here to radius. And so your radius gets equal to whatever radius gets passed in as, and diameter gets set to whatever radius times 2 is. You can have any code over here you want. Okay? You could even have area in here and have the area be, instead of this method here, it could be equal to some definition, and it doesn't get called, it just gets set one time. That's a way to do it, but the better way would probably be to have there be a method that calls math.pi times this.radius, because if we change the radius of the circle in the future, then its area would update as well. Its area would update as well. And if we had the area be set inside the constructor, it would only get set one time when the function gets created the first time. And if you update the radius in the future on that circle, you won't get the updated area because it'll have already been computed. It'll have already been computed and assigned. Same thing with circumference. These two depend on the value of some state in this object. And the state that it depends on is, this one depends on the diameter, and this one depends on the radius. So really, they both depend on the radius, right? So if the radius changes, well then the area is going to update, but what's going to happen to the circumference? Well, this one here is going to be equal to diameter is equal to radius times 2. So let's see what happens. Let's see what happens. So if we,
Just real quick,
yep.
could that be constructor argument is just like number and then this dot radius equals number, this dot diameter?
Yeah, the name radius here is actually whatever you want it to be. This you could have this be number, the name number if you wanted. And then it would be radius equals number and diameter equals number times 2. But then radius is now a property on this object. So you could still refer to radius down here in area by saying this dot radius. Because radius is a property, the argument number was just whatever got passed in when you called circle with the new keyword. So I'll show you that in a second. So here's how you would use this definition. You'd use it like this. You'd say var circle equals new circle taking some number, and circle.radius would then equal 2, and circle.area equals a function, but if we call it, it gives us back whatever the area of the circle is. Okay, note here, this is important, when we call circle with the new keyword, it has to be capitalized. It has to be capitalized. And that's because this here, this circle, is a variable circle. The variable capital C circle is the variable name. It is the variable name capital C circle. So if you use lowercase circle to call new, it's not going to know what that lowercase circle variable points to. And it'll instead give you an error. It'll give you a name error. It'll say lowercase circle is not defined. Okay, so we'll see some examples of that in a minute. All right.
And then under that, you could have var double circle equals new circle 4.
Exactly. It's exactly right. That's exactly right. Let's see if we have that on the next page here. Let me zoom back out. So classes, just to kind of close up this concept, classes in JavaScript are a template, or in JavaScript parlance, a prototype that allows us to build new instances of that prototype. Okay? You'll hear the name template or prototype or blueprint thrown about depending on who's saying it and what language they're familiar with. But that is the typical way to describe this way to create objects. And classes are for making lots of objects with the same methods and different data. So you want the methods to be the same, but you want the data to change. Methods to stay the same, but you want the data to change. And you don't want to have to write out the method every time you create that new object, because that's a pain in the butt. You don't have to do that every single time, right? So in this case, the class is your cookie cutter. If you're baking a bunch of cookies, you have your class as your cookie cutter, which is the shape that's going to cut out the cookie. And then the instance is the actual cookie that you're making. If you're making 12 cookies, it's one cookie. All right? And the data is like if you put different sprinkles on it, or if you put different icing on it, or maybe if it's a chocolate cookie instead of vanilla cookie, or whatever. Those are the instance data, all right, of that cookie. Does that make sense? I'll try to show you some code to kind of put this together really quick. So there is this principle called complete construction, okay? And what it says is that after the constructor executes, that the object is in a valid state. That you don't have to reach into an object and tweak any dials or call any methods in order to confirm that the object is good and it'll work as it is. If the object is not good when you call it with the new keyword, instead of getting an object, you should get an error. Right? If you pass in the word blah into a circle, you shouldn't get a circle with a radius of blah. You should get an error instead, right? Or something else like null or undefined or something like that. But probably an error in this case would be better. Because you don't want to have a circle that's not valid. That would make your program hard to use. And you might forget how you intend to use your program in the future. You think that your memory is perfect now, but you're going to write lots of programs in your career as a programmer, and you're going to forget the way that you intended to use parts of your program in the future. And so by making your parts of your program be independent and safe, it's easier for you to use them in the future. It's easier for your coworkers to use them too. So in practice, what this means is that when you create an object, you want to pass all the initial values that you need in order to make that object work into the constructor for your object. You don't want to pass in a number 2, but also need a color. You need to pass in some values and have them be either required or be default, so that what you get back is a clean, complete, coherent object. Okay? And that principle is called complete construction. All right. So here's what we mean by validating your circle. Okay? So what if we had a circle with a negative radius? What if we had a circle with a negative radius, right? So if our radius was -1, well, that's not really a circle, right? We can't have a negative circle. I mean, you probably can in some, I don't know, if someone's a mathematician here and I'm totally wrong, then correct me. But I don't think that you can have a negative circle unless you're in sort of like a weird hyperbolic plane.
You get a negative circle. So.
What's that?
You get a negative circle.
You get a negative circle. So you can't have you have a circle with a negative area, right? So anyway, in this case, if we had a circle that accepted a radius as a parameter, so a circle would be on the complex plane, says our mathematician. So that's awesome. Okay, so there can be negative circles. I just don't know about them. So if your radius is less than 0, then we want to throw, this is a new word that we haven't talked to you about. What this means is that we're going to raise an error. And the message is going to be radius must be a positive number. So the error that we get is what's called a runtime error. That's what you get if you don't have a special error, but you just say the word throw. And then the message is going to be whatever is inside of the call to throw. So it's like we're throwing an error, and if there's nothing to catch it, that error goes all the way up to the top of the program and stops the program from running. Okay? We haven't talked too much about exceptions and error handling yet, but just keep that in mind. We can throw errors, and errors stop the program if they aren't handled. If our radius is greater than or equal to, if our radius is greater than 0, not equal to, if it's greater than 0, then we set up this.radius equals radius. So inside of our constructor, we can have however many validations we want to make sure that our object is going to be safe and usable and complete. Yeah, Missy.
It won't be on the complex plane because the radius represents a distance, and distance is value of a square root.
Okay. So it will not be on the complex plane. I've been corrected twice now.
Sorry.
This is great. I love it. I didn't think that you could have a negative circle, so when you said that you might be able to have one, I was like, oh, that's cool. That's good information for me. Now I know both sides of this coin. Okay, so we have a radius, and we know that it's positive, right? It's not negative. So this is a safer circle. It's a safer version of circle. There's one other thing here. If we have radius is less than or equal to 0, well, we could possibly, what if we had a string here? What if we did string less than or equal to 0? I don't know. I'd probably have to run that in the JavaScript console to tell whether or not if it compares to a string to 0, if there's some kind of weird kind of conversion that tries to take place in order to compare the two. I don't think that it would actually compare them. I think it would raise an error, but it might. And so sometimes it's good to actually check that stuff out. The if statement in this case is what we call a guard clause. What it means is it guards against the creation of an invalid object. And it guards against bad values entering your program or your algorithm. And you can also call this asserting your argument. So it's like you're asserting that your argument is greater than 0. It's like a little mini assert, but we're not using the assert word. We're just stopping the program if it is 0 or less. And validating is a really valuable feature of object-oriented programming because what it does is if you do it right, then if your program runs, you know that your program is valid. If you do it, if you have a procedural program and you don't validate your inputs as they go into your procedure, and some part of your procedure makes a mistake, has a bug, it can be really hard to determine where the bug is in your program because your data is flowing through the program. It can sometimes be hard in object-oriented programs too, but if you do a lot of validation when you create your objects and you just have objects talk to each other, then you can have a lot more confidence that your program is running correctly. All right, so you can be confident that your program is running and that you've checked for bad data or boundary conditions in your program. So that's the last lesson here. Let me show you really quick what this class keyword looks like when we actually use this. So here we have our circle. And let's bring open the console here and put this over there. And I will delete everything that's already in the program, just so I don't get two circles, for example. So I'm going to say let circle equal, no, I'm sorry. I want to first create my class circle. And let's put in our constructor here. So this is our basic circle. So if we said let circle, let's say small circle equal to new circle, and then this is going to have a radius of 1.
Misspelled circle.
Thank you. Still wrong. There we go. So this is going to have a radius of 1. So now we have our small circle here, and we get back a circle. Notice how this doesn't say plain object anymore. It's not just a plain object, it's an object with a type of circle. You see the name to the left? And there's a diameter and a radius. And if we say small circle dot diameter, sorry, not diameter, if we call circumference, and we call that, we get 6.281318530.7. And if we call with area, well, we get back the area, 3.1415, right? So that seems right. But if we were to call another circle, so I'll call this one wrong circle, and this one would equal, I'll say let here, new with a circle of -1, right? Well, wrong circle has a radius of -1 and a diameter of -2. So if we say dot circumference here, well, we get negative 6.28. Well, that's not right. You can't really have a negative circumference. And if we did area, well, we would get, again, incorrect because we have a negative radius but then a positive area, so that seems like that's wrong. If we instead on our slides here did our constructor as we had before, so I'll say I'll reset. I don't think I can do. Let me see if I can redefine class. I don't think that I can redefine the class, but if I can't, I'll just do a refresh. So inside of our constructor here, we want to have an if statement. Yeah, identifier circle has already been declared. So let me refresh really quick. And inside of my constructor here, if I do this right, and if I do shift enter, it will not evaluate. So let's do some stuff in here. So let's say if radius is less than or equal to 0, then we want to throw. The must be positive, so let's do throw. And I'll just say must be positive, like this. And I'll make this a little bigger so it can be red, and maybe I'll stick it on the bottom so that it's a little easier to read. So it says must be positive. Otherwise, the radius is set. Otherwise, the radius is set. So let's see what happens now.
You need a parenthesis on the.
Oh, did I screw it up? I totally did. So let's see if this will allow us to work, or if it'll yell at me about this. Let's see what happens. Cool. So now I can do my wrong circle equals new circle with -1 as its radius, right? Okay, so I don't get back a circle. I get back an error. And that error is uncaught, must be positive. What this means is that I have an error get thrown. That error should be a runtime error, and then the value is must be positive. So my message could probably have been better here, but that works okay. That works okay. It tells me that something in my program is not working, and if I open up the error and I look inside of my circle definition here, I can actually click on the circle and see that this is where the error was thrown from. So I can see that if radius is less than or equal to 0, then this gets thrown. So that's telling me that radius here is less than or equal to 0. Okay, and if I wanted to see the next line of where it was thrown, I can click on, the original line of where it was thrown, I can click on this, and this will tell me the actual line of usage that caused that error to throw. So the way I'm doing that is I'm just expanding the error and then clicking on one of these links. And you note that this has this weird cryptic VM 1429. That's just telling me that this is the part of the runtime code that actually threw this. And this is another part of the runtime code that threw it here. And if I called this again, they'd be different. And I'll show you what I mean by that. So if I do this a second time, I need to have this actually be like this. Uncaught must be positive. And now they're actually different numbers, right? The line numbers are the same, 1406 and number 3, but the initial one, 1429 or 1547, those are different. Okay, this is my code, and this is the actual as the JavaScript is running, where does it initialize from? Okay. Who wants me to cover some more stuff on classes? It seemed like there was some interesting questions on classes, so I want to see if I can answer any of those before we go forward from here. So I've got 2 questions, Connor and Missy.
Should all classes have getters and setters?
Yes. Yeah. So
No, I didn't hear what you said.
I asked if all classes should have getters and setters.
Oh.
when you define them like this, they will. when you define them like this, they will. And the reason that they will is that in JavaScript, when you have a constructor like this, you're creating a property radius and you're creating a property diameter. And it's not going to be possible for you to be able to have a constructor that sets a instance property, which is what radius and diameter are, without your ability to also change them. And I'll show you what I mean by that. So this is a really, really good question. Let me just remind us that we have a small circle. So we have a small circle right now. If I bring this up, open, we can see the small circle that we have. If I said small circle here, oh, it's not defined. I actually didn't define that yet. So let me do that really quick. So small circle. Yeah, I cleared it. Thank you so much. Equals new circle with a radius of 1. Okay. So small circle dot circumference, and it's this 6.28318. Now, if I change small circle dot radius equals 2, this is sometimes these are called a setter in other object-oriented languages. So my radius is now equal to 2. If I look at small circle, radius is 2, but diameter is also 2. So our diameter, when we initialize the object, it doesn't update the diameter based on the radius, which is like actually a bug in our code. And I'll show you how we could change that in just a moment.
Because it was basing diameter on what you fed it.
Yeah, it was basing diameter on the radius that was passed in. So it's basing diameter
Like that's why
on
I
this
asked
radius.
if radius would be better named as like number or something, because the way that's written is kind of confusing.
Yeah, well, changing it to number won't make diameter update correctly.
Not if
No,
you-
but it's confusing
You
in
have to
that
write like
this
circle dot
radius
radius
equals.
times 2, or this dot radius times 2 to make it work. Diameter equals this dot radius times 2.
That would work when it sets it, but and the problem is that it still would not update it. I'll show you why. So if you do, I don't think that it would update it each time. Let me double check. So if let me refresh this, come back up to my circle definition here, and now let's add this dot diameter equals this dot radius times 2, right? And let's change the number, just change the name rather to number, just because we asked about that. So if we change it to number here, and we say radius equals number, now this dot diameter is going to be equal to this dot radius times 2. And now everything else references either this dot diameter or this dot radius. Okay? Everybody see that?
Does the if radius less than 0 need to be number?
Yes, it does. Thank you very much. So this needs to be number. Yes, correct. So now if we run this to create our circle class, and then we create a new small circle with a circle equal to 1, we have our small circle. With a radius of 1 and a diameter of 2. Now if we if we change small circle dot radius to equal 2, and we look at small circle again, we still have a diameter of 2. The diameter didn't update. So what can we do to this to actually make the diameter update? Make it a what?
Make it a method.
Make it a method. Yes, that's exactly right. So if I refresh the page and I come back into my definition here, and instead of saying this dot diameter equals radius times 2, if I actually get rid of this, and now let me see. Oh, I don't want this to be uppercase number. That's wrong. I want this to be like that. And now down here, I could say diameter and have this be a method. And that would say this dot radius times 2. Okay, and now with that, we can
Return it in this case?
well, yes. Okay, so yes, this is a method, so we need to return it. So this would return that value. Thank you, Ron. The other thing we could do, if we didn't want to do that, is that we could say that the diameter. No, that wouldn't work. I was going to say that the diameter method we could change it to something called an explicit setter by saying something like, set diameter here. And that would, instead of returning a value, it would do something like this dot diameter equals this dot radius times 2. The problem with that is that now set diameter has to get called for diameter to actually be set. So instead of doing that, if we just set it to diameter equals return this dot radius times 2, then what we get is that when this calls this dot diameter, what it does is it looks up the value of this method call here, it gets back that value, and then that should become the number that you multiply math.pi by and get a result. Let's see if it works. I think I don't have any syntax errors, but sometimes I'm wrong. So if I now say let small circle, I want to be able to, yeah, there we go, 1. So now we have small circle here, and it has a radius of 1. That's the only instance property that's now inside the circle. So if we say small circle dot diameter, and we call it, it gives you back 2. But we have to call it. It's not a property anymore.
So what would happen if you set the property to be equal to the method? Does that even make sense?
So you can't set a property equal to the method because you can't have 2 method names of the same thing. But what you can do is that,
Like if you wanted it to display as a property when you just looked at the object and didn't want to have to call it, I guess you're just talking about 2 different things then.
yeah. So what you can do is you can do a thing that's you can do something like what you're alluding to, and let me show you how you could do that. So if instead of doing what we did, if you have your circle and you have a constructor that takes in a number and it sets this dot radius equals to number, and then it sets this dot diameter equal to this dot diameter equal to set diameter. Okay. Then what happens is that you can have there be a set diameter method down here, and set diameter does 2 things. It says this dot diameter equals this dot radius times 2, and then it would also, you can do this so that it can return, after it sets the property, it can return this dot diameter afterwards. Okay, so I'll just put in the semicolons for niceness here. The thing is now, though, is that when you have something like this, and you call small circle again. Oh, hold on. Set diameter is not defined. Oh, it hasn't been defined yet. Oh crap! I have to say this dot self diameter. That's my mistake. Let me refresh. So this will look up what the value of set diameter is, and we have to call it. Hold on. We don't want to set it in here. We actually want to just call it. We actually call this dot set diameter. Because by calling this dot set diameter, what you're doing is that you are now saying this dot diameter equals this dot radius times 2, and then returning this afterwards. We're not doing anything with the return here, but that's just kind of like good practice to return a value rather than returning undefined. Now if I call this, we say small circle, and we get a radius of 1 and a diameter of 2. So it sets it when it gets set up. And if we say small circle dot diameter equals 2, this is the tricky bit. It's you would think that it's going to set up diameter again, but if we look at small circle, not diameter, oh crap, I meant to say radius, sorry. My mistake, sorry. Radius equals 2. You'd think that it's going to set diameter again. It still doesn't. And so what you have to do here is that you have to create a special kind of function on this class called a setter function for diameter, so that when you change the value of radius, that whenever that value changes, it calls some setter function that resets the value of other state in the actual object. And let me show you what that looks like. Okay, so to do that, I'm gonna show you the MDN page on setters, the MDN setters, getter setter. Hold on, getter setter. So setter in JavaScript is a special syntax, and what it is, this isn't in the class. This is the way that they're giving you as an example here is not using class. Okay, it's using this special set, and then current and then name, and it says this dot log dot push name, and log is an array. And that array is a property. So when you say language current English, current is the method that gets called, and this is the change that gets applied. It comes in to the current method with name, and it calls this line of code, this .log.push. Well, log now is an array. So if we look at log after calling current English and then current FA, well, what you get is language.log is English and FA. So what set is that it's a special syntax that it binds an object property so that when there's an attempt to set the property, it does this special thing instead of just changing the value. It changes the value and runs this code every time the value changes. Okay? So that's like the tricky bit about setters and getters in JavaScript. You can do the same thing with getting as well, meaning that if I go to, let's see if there's so there's getter as well. And get is another keyword that is a function. And instead of just returning the value of whatever that property is, it also runs all this code when that property is accessed. So in this case, if we had an object or obj object with a log of ABC, and we set up a property called latest, it says if this.log.length equals 0, return undefined. Otherwise, return the length minus 1. So this would give us the output of C, right? Even though the log is not the value C, the log is a whole bunch of different characters. So it sort of gives more flexibility around those particular properties to behave in ways that exceed a simple retrieval or setting of a value. Okay? That's what a get in a set is in a JavaScript object. That's different than just a simple access. So I wonder, I haven't run this yet in a class for a while, and I'm forgetting how it works. So I wonder if we can do this in a class, right? So in a class, if we have our, let me see if let me refresh just to be safe. So if we come into our class here, we have our circle. So we have our constructor number, right? Our constructor number sets up our radius, which is equal to number. And then we say this.set diameter. What if we just didn't have that? What if we just didn't have that? And instead, we have this set diameter thing. Well, what if we say get with diameter, right? So get diameter as our method. And let's see, yeah, so this is actually going to have these at the end. And we're going to say this dot radius times 2. Like this is what we're actually going to return, right? We're going to return this. And then we can remove this line down here. So now diameter, instead of being a method that we have to call with open and close parentheses, I think we'll be able to just call it as a property. Just call it as a property. So if we do this, right, and we reference diameter and circumference, let's see if this actually works. Let's see if this actually works. So if we say small circle equals new small circle 1, and we say small circle, and we call it, well, it says radius 1, right? If we say small circle dot diameter, well, it's 2. It looked it up correctly. So if we say small circle dot radius equals 2, and now we say small circle dot diameter, oh look, it's 4. And
Can you
what?
scroll back up to the code?
Yeah,
Sorry.
totally. Let me make it bigger. So this is the code that made that work. So instead of using just the word diameter with a open and close parentheses, we prefix that word with a special keyword get, which means that this is going to be more than just a simple property, and it's more than just a simple method as well, because it behaves like a property that runs some code before it gives you the results. It runs this code, in fact, before it gives you the result. So it's checking the radius when it runs, and then it's returning the radius times 2. So you don't have to call diameter with an open and closed parentheses like it's a method. You can call it like it's a property, and it acts like a method. It acts like a method that looks up the radius and then gives you 2. So that means that now when we use it inside of our call down here, when we say circle dot circumference, and we call that, we get the right circumference. And if we call small circle dot area, well, we get the right area with the right radius, right? Because our small circle is still a circle with a radius of 2. Okay? Does this make a little more sense? Maybe?
So the set and the get are like functions, but because of the way that syntax, it makes it appear like it's a property.
Now you could also have done what I did, but by using a setter instead of a getter. What would the setter be we'd need to do in order to make it behave the same way?
You put it on radius.
you'd put it on radius. Exactly right. When we set radius, we would want to update another property. The property we want to update, we'd probably want to set some self.diameter. And we want to set self.diameter to equal radius times 2.
Self or this?
You would need to do self.diameter because because you're using a setter and not a getter. You want to create an instance property called diameter when radius is set, even on the constructor. And when it's set, you create this instance property diameter, and that creates the diameter. Let me demonstrate for 90 seconds to show you the other way to do it.
Dr. Seuss novel.
Yeah, it's a little bit like that. Yeah, sure. How do you think I feel? I'm the one who has to get the words right. Oh boy. So
What would we know if you didn't?
so if we said set and we said set radius, okay, and instead of saying return this dot radius times 2, if instead of that we said this dot diameter equals this dot radius times 2. Let me see if this works really quick. So let me just back this up to setters really quick. Oh, yeah, I need to have it take a value, of course. That would be my mistake. Let me come back into here. So the setter for radius has to take new radius. I'm just going to do it like this. And this is going to be new radius times 2. This is the setter. Yeah, I think that would work. Let me make sure. Let me try it and see if it works. I might also have to set this dot radius equals new radius. But let me just try this really quickly. So now we have a circle. So let's do let small circle, small circle, small circle equals circle 1. So we have a small circle here. And oh look, see, diameter is set to 2, but radius has not been set. So that's the trick. So I do, in fact, if I were to do small circle dot circumference, this should, the diameter is 2 to the radius. So let me do small circle dot radius is undefined. Oh, you know what? It's because I need to do area. That's the one I meant to call. So that's nan. So in fact, in the definition, I need to refresh this page one last time before we break for the night. And in the definition, in addition to setting the diameter equal to the radius, I need to also set the this dot radius equals radius. I think that equals new radius. Thank you. And this might break because this might be recursive, but let me just see. So if